A simple rational equation, which is also sometimes referred to as a proportion, is one that's in this form here, where we could describe that as just a fraction equals a fraction. A single rational term on each side of the equation. If there are no additional terms, and also no common factors in the denominators, then we can solve this by our kind of standard process of finding the LCD and multiplying it by both sides. But it turns out that process will always yield the same result, which we could get by cross-multiplying. And what cross-multiplying means is that we take the numerator from one side and multiply it by the denominator of the other side. So this x is going to get multiplied by 8 minus x. And then on the other side of the equation, we will take the numerator of the other side and multiply that by the denominator of the first side. Doesn't really matter which side goes on which, so that's going to be 3 times 4. And in between here we have an equals. So now we are already at the stage of having cleared the denominators, and we're ready to go ahead and solve the equation. So all this is a brief shortcut where we don't have to go through the entire formality of finding the LCD and multiplying it by both sides. So I'm going to distribute in on the left-hand side. X times 8 is 8x. X times minus x is minus x squared. And of course on the right-hand side, 3 times 4 gives me 12. This is again a polynomial equation, so we do want to get all of the terms on one side, and I am going to choose to do that by moving these two terms to the right. That will give me a positive x squared term, a positive coefficient for my x squared term. So I'll get 0 on the left, and on the right hand side I'll have positive x squared minus 8x. Both of those terms changed sign as they moved across the equation. And then plus 12, the 12 retains its original sign because it did not move. I have now a polynomial equation, but it's one that's fairly easy to factor. So I can factor this. These are both going to be minus in this case. We have a positive product for our last term, so they have to both have the same sign. For us to get a negative sum of the outer and inner terms, these must both be negative. So 2 and 6 are the numbers that work. And setting each factor equal to 0 gets me x equals 2 and x equals 6. A quick check against the domain on this equation. The only denominator that could possibly equal 0 is 8 minus x. This tells me that x cannot equal 8. The denominator of 4 does not give me any domain restrictions because it doesn't have an x in it. X could be 4 or negative 4 without causing any problems there. It's only when there's an x in the denominator that we get any contribution to our domain. So x cannot be 8, but 2 and 6, neither of those is equal to 8. So we could write our solution set as just the values 2 and 6.